Hello, welcome back to Mastering Statistics. We're going to solve another problem in hypothesis testing with two variances. Again, this will be a right-tailed test. That's kind of giving away a little bit of a punchline ahead of time. So what we need to do is read the problem first of all. A researcher thinks that men have a higher variance in cholesterol levels than women. So we think men have a higher variance in cholesterol levels than women. To test it, he samples 8 men and finds their variance to be 227. He samples 7 women, finds their variance to be 89. Test this claim at 0.1 level of significance. Now, a few things I want to point out before we even write anything down. The first thing is, when we do the sampling, we sample 8 men and 7 women. So, as I mentioned in the last problem where we did 20 pencils from each plant, you do not have to have the same number of samples from each population. So here we're doing a different number of samples in each population. That's number one. Number two, just kind of look at what the problem's saying. We think that the variance in men's cholesterol, so this number here is not the mean of their cholesterol. It's not the average value. It's saying that we think men are all over the map. It means men's cholesterol levels, we just suspect or think, the claim is that they're just widely dispersed. Some are low and some are high with a much more wide dispersion, which is what variance is measuring, than the women. And you can see that the men's variance is 227. Higher number means the data is more spread out about the mean cholesterol for men. And the women, their variance is much smaller. So when you look at these problems, you immediately want to say, well, of course it's true. But the problem is it may not be statistically significant because we only looked at 8 men and 7 women. That's not a very, very high, number of people that we're testing. And we're also only testing at a 0.1 level of significance, which by now you should know corresponds to 90% level of confidence. So it's kind of high, but not like 99%. So the hypothesis test puts all this stuff together to figure out if it's statistically significant. So we have group 1, which we're going to call the men, and then we have group 2, which are the women. I always recommend when you solve problems to write everything down that the problem says, because then you can understand what's going on. So we sample N sub 1 is 8 men, right? You can see that from the problem. And the value that we got for their variance from those men that we're sampling, S1 squared, we got 277. Pretty big number, pretty widely dispersed cholesterol, higher variance, right? N sub 2 was how many women did we investigate, and we looked at 7 women. And the variance there that we looked at was, or that we calculated, S2 squared, was what? 89. And then the other piece of the puzzle is that the 0.1 level of significance, we now know that alpha is 0.10, which take 1 minus that, you get 0.9, which is 90%. So that's 90% level of confidence, 0.10 level of significance. Now the next thing you need to do after you write the data down is to write down the null hypothesis and the alternate hypothesis. It's always helpful to write the alternate hypothesis first because the alternate is the claim that's being made in the problem. So you see a researcher thinks that men have a higher variance than women. That is the claim. That's the alternate hypothesis right there in the first sentence. So the way I always do it is I come down here and I write the word claim because it helps me zero in and focus on that, and I know the claim is always going to be the alternate hypothesis. And then I write down what it says. It's saying the variance that in men's cholesterol is higher than women. But we don't want to use S1 squared and S2 squared because the claim for the hypothesis is dealing with the whole population. We're using this data to figure out what the population behavior is. So when we write our hypothesis test, we write it in terms of the population. So when we write the hypothesis test down for the alternate, what we're saying is that the variance, sigma 1 squared, in the men's population, group 1, remember group 1 is men, group 2 is women, so that's why we have the number 1 there, is greater than for women. That is the claim. So I go ahead and write this down, and just to remind yourself, this is men, and this is women. Just to help remember, right? Now, once you have the alternate written down that men have a higher variance than women, then you can go and easily just above it write down the null hypothesis, which has to be the exact opposite of that. So you literally write everything down the same, sigma 1 squared, sigma 2 squared, except you flip the direction and you have to stick an equal sign under it. So basically, the null hypothesis, which would be the accepted guy, has to be opposite of the claim. So either these variances in the cholesterol are equal, or maybe